My name is Teresa MacDonald. I'm the Associate Director of Informal Science Education at the KU Natural History Museum. And I just wanted to share an IMLS funded project that we did over the last year and has been launched. And it's Natural History Mystery, which is essentially like an escape room, but in a backpack. So it's sort of like a mashup between an activity backpack and an escape room that uses props and tools in a backpack and also things in our exhibits. So I'll have time for questions, but if something jumps out, please just yell and I'm happy to answer that. So I'm just going to talk a little bit about how the game works and then some of the findings we found as part of the evaluation. So it was a lifelong learning grant from the IMLS, and the idea was to basically test this idea about doing an immersive sort of self-guided escape room in a natural history museum, basically using our objects. And so we had sort of 4 goals, which was for it to be fun, have a good time and remember it, getting people to think about evolutionary relationships. So an area I'm interested is in tree thinking and tree reading skills. So again, getting them to think about common ancestry and evolutionary trees, and to specifically get people to at least start to think about the idea that natural history collections can be useful for solving problems, biomedical problems. And I'll talk about the way that we do it in a very broad sense. So we had a whole list of parameters. So I worked with a colleague at the University of California Museum of Paleontology, Anna Thanukas, and we had a whole list of things that we used to decide important criteria for designing our game. So we wanted it for small groups, ages 7 and up. It had to use exhibits. It had to be science focused. So you needed to be using science to actually solve the puzzles. We wanted a single path. We wanted everyone to win. Unlike most escape rooms, the idea is you build them so that only a percentage of people can escape, but we want everyone to escape or finish, although they're not locked in anywhere. And so this is just an idea of the things that helped us make decisions about choosing puzzles and what to drop and what not to do, and also minimal reset time, since these are available at our front desk and the visitor services staff need to be able to facilitate that for visitors. So group size is 2 to 5 players. That's important to make sure that people are working together, but also to make sure that everybody has a chance to do something. Any bigger than that and it doesn't work particularly well. This is all the stuff that's in the backpack, so I'm just sort of going to walk through each puzzle and how it works. We actually didn't do a time limited for this. We didn't say you have to complete it in an hour. Although with testing we did with college students, we found that some of them would like that option. So they like the idea that they could say how long it took them to do, the idea that they could compete with other groups of friends. So that's an option we're going to give people, but we don't set a time limit. And some groups take an hour as typical. Sometimes groups take 45 minutes. Sometimes groups take an hour and a half. And one of the things that we've seen people do is they play the game, but they actually stop and look at other exhibits and talk about how they connect to the game. So we wouldn't want to discourage that kind of thing. So the general overview of the game is that there's a backpack with all the props and tools. Then they get this data matrix, a data sheet, and they have to collect information for these 5 groups of vertebrates, so lizards, tapirs and rhinos, bears and cats, frogs and salamanders, and bony fish. And then they look at 4 different traits. So they solve a puzzle, they answer that unlocks the next pocket. Okay. And then they get a laminated map, which is pre-folded for them, but they can unfold it. And I'll talk a little bit about why we do that. So that's the sort of general overarch as they solve these puzzles as they go around. So the first puzzle is toes. And so this takes them to our big Explore Biodiversity exhibit. And they have to look at the number of toes on the back foot by looking at objects. And then that gives them the code to unlock the next one. The Explore Biodiversity exhibit is a double-sided exhibit and has over 530 objects. And the props they get are 5 Polaroids. And the Polaroids don't show them the toes, but they circle the specimen they're supposed to be looking for. So they have to find this bear, then they have to look at the foot, and then decide it actually has 5 toes on the hind foot. So that's the first puzzle. We like to start with this puzzle when we're doing a sort of set order, just because it seems to be the easiest and the most accessible for people to think about toes. Once they've unlocked that, that takes them to the panorama, which is one of our signature exhibits, and they're looking at the side of the lower jaw, whether it's one bone or not. So this is a photograph of our panorama. It's an almost 360-degree diorama of North American biomes, and we take them to a few different places. So they get 3 what we call X-rays, and I'll show you how that works. And then they get a clue card. So this is what they get in their pocket. And so they are prompted to use the X-rays to find the 3 groups of animals: bears and cats, lizards, and then rhinos and tapirs. And then they read the clue off the card. So this is an example of, this is what the X-ray looks like, and they have to find the tapir, and then they hold it over where the tapir is, and then they're able to use this X-ray of the tapir to look at the lower jaw. The side of the lower jaw is a single bone, yes, so they record that in their table. For this clue card, they notice that all the capital letters spell fold map, and on the back of their map there's this image, and if they fold it together they get the icons for the bony fishes and then the frogs and salamanders. So this is one of the things people really like. They often make connections to things like Romancing the Stone, depending on the age they are, or Mad Magazine, again, or different puzzles like that. And people tell us they really like the fact that the map is used in multiple ways. So it's used to navigate, but it's also used to solve some of the puzzles. That takes them to the protected egg and embryo trait. And so that takes them to another floor where they look at an exhibit about invertebrate animals. And what they get here is they're supposed to look at this exhibit of invertebrate animals, and then in their backpack that they've unlocked the pocket for, there is a worksheet related to the tree, a puzzle that they have to put together, which is really a copy of this phylogeny back here with a little bit of information added. And then they basically have a box that's locked with eggs, and they have to solve this puzzle sheet to unlock their egg box. So they put their puzzles together. This is the tree that they get, and they're asked to trace different lineages to answer these questions at the bottom. That gives them the code to unlock the box. And then they get a set of eggs, and that tells them yes or no for whether these groups have that shared character. So then they fill those in across the base, and then that takes them to their last trait, which takes them to the short-legged rhino exhibit that we have, which is just around the corner from there. And here they're looking at arm bone patterns. So whether they have a pattern of one to many. So this is the exhibit they're directed to, and in their backpack, they get a clue card here, they get a UV flashlight, they get a magnifier and 2 casts with painted limb bones. And so for the rhino, they answer it at the rhino phase, and this image here is basically a replica of the rhino image to just help them with that first answer. Then they read their clue card, and they see here that they can use the casts that they have for some of the groups, and then they can use that, but they don't have the answers for bears and cats and bony fishes. But the card gives them a hint to look at it in a whole new light. And if they use their UV flashlight on their map, they come back to the map, and it tells them to find the saber-toothed cat and Orzophanctinus fish. So again, going back to using the map for other puzzle pieces, and then they go to the saber-toothed cat, and then they look at the fish. So typically groups end up at this last station with our bony fish. Then there's final puzzles. So inside the main backpack are locked final puzzles. And one looks like this. It's basically a giant vinyl map with all the locks again. So all of the answers they've got here, they have to unlock these again to get into the final puzzle. And then there's a box with a lock on it. So when they open that vinyl map, they get a giant vinyl map 4 evolution clue cards and 5 taxa cards. And they have to use, sorry, let me just reject the call. Someone's calling me. And they have to figure out by reading the traits, using the evolution hint cards if they need them. Most of them use maybe 1 or 2 of the hint cards, depending on their comfort level. And then they use their matrix as well. So they use all this information to basically place these taxa in the correct order. Okay, so they have to put them across the top. And so the sort of narrative that they read, they're given a story to read about their mission at the beginning. And the mission is they need to answer these questions because there's been a disease that's been found. And we want their help to figure out which group carries the zoonotic disease so we can solve the problem. So that's the sort of overarching narrative, which ties to how collections are useful. So once they've done this, they've identified which one carries the virus, and they look at the capital letters of the order across the top. That unlocks the final box. So they basically have to use the tree reading skills and the identification of all the traits and these hint cards to complete this mat, get the order. That unlocks the final box. So this is the order to unlock the final box. Inside the final box is a little plush taper with a recording. And when they push that, it tells them, congratulations. They solved the natural history mystery. Great job. They worked together. They learned about evolution. And then they can collect, I solved the natural history mystery stickers. So they get the stickers to say that they've solved the puzzle. Then groups just throw everything back into the backpack and it goes back to the front desk, and then it gets reset. And this is a group of my staff who played the game for me. And this is the fish in the back area. They don't have to finish there. They can do this last puzzle anywhere, but that's typically the order that people do it in. In terms of evaluation, it was found to be fun and memorable. So we did multiple rounds of evaluation. So we started with paper pencil versions, and then we moved quickly to more substantial permanent versions. And we did testing with families. We did some testing with first-year college students. I did some testing with youth groups, typically around that 4th, 5th, 6th grade. I also did some testing with some 7th grade groups as well. And then we had an external evaluator do some summative evaluation for us, but we found it was fun and memorable. They had a lot of fun. They were engaged. They liked the puzzles. They liked the meta puzzles. And a lot of people said they liked how it made them connect exhibits to each other. And so often people would tell us that they learned how to look at exhibits as being one of the big skills that they took away from the game. Spark conversations about relationships. Yes, they certainly did. They had to talk about that and correct each other or agree to basically solve the puzzles. If they escape, so to speak, or if they solve all the puzzles and succeed, then they've had to learn how to read it, how to get some basic tree reading skills. They report that they learned about content, things like they learned about arm bones, that you could compare them between animals. Some people just said, I learned that fish have bones, which is something that hadn't occurred to them before, or about different groups of animals. And then they also talked about things about common ancestry and shared characters. They talk about evolution during the game, and they use the idea to solve the puzzles. Sometimes younger players don't necessarily use the word evolution, but it's clear they're talking about those kinds of ideas. And any young player who we asked to place a card, so one of the things we did as evaluation is gave them another trait and said, where would you put this on the tree diagram at the end, and to see whether they could place it correctly, but also explain why they put it there. And everyone that we asked to do it was able to do that. And the players self-report feeling they know more about evolution. So we found that was statistically significant, their reported knowledge or how they felt they knew about evolution. And then goal 4, which is we wanted to look at just if we just created the idea of zoonotic disease and how collections could help with that kind of information or understanding natural history, we found that they were much more likely to agree that evolution can solve and prevent biomedical problems. And again, this was statistically significant, which was great to see. And so, in fact, we just had a paper published in the Journal of STEM Outreach about the project, specifically looking at our evaluation information, how we built the puzzles, and how we found that. So that's a sort of overview of the game. So just open for questions that anyone has about how we designed the game or specifics about evaluation.